You can't just walk outside. You can never just open a window.
On Earth, we have floor, walls, and ceilings. However, microgravity, when you can float around, everything can become a floor or a wall or a ceiling.
Well, regular architecture is everything you see from houses and apartments to skyscrapers and everything here basically on planet Earth. Space architecture is literally architecture in outer space, lunar habitats, Martian habitats, crew transfer vehicles.
Living on the Moon or Mars, it will be really challenging. Of course, it will be very interesting too.
The windows are very important for the crew members to be able to view out, to make that connection back to Earth, because you are isolated and confined here on the Moon.
My name is Candy Foyer.
My name is Christopher Lloyd.
We're at the Sasakawa International Center for Space Architecture, part of the University of Houston.
My name is Chris Kennedy. I work at the Johnson Space Center. This facility here is where we can test out concepts, habitat ideas, designs, and requirements as we move forward and plan for the lunar base or the lunar outpost. As a space architect, I'm interested in understanding the environment and the habitat that they're going to live in for those 6 months.
You think about how much area and volume you need to provide, how you will be arranging everything within this, small volume.
Volume and area and calculating these things is just crucial. And it isn't like here on Earth where you can take up a little more space here or open a window here. It's all enclosed.
You have to be very efficient and you have to be very functional. You go inside and you think how you can use its volume and its perimeter in the most efficient way. So where you can put your equipment, you have to use every square inch for some purpose.
My current project is a Martian greenhouse. In order to complete a mission to Mars or somewhere that far or that long of a duration, we need to figure out a way to grow our own food there. The greenhouse basically works by having each individual plant in its own bubble. Basically, the plants grow without soil, just water and fertilizer. Once it's been mixed, it then is sent up towards where the plants grow. There's piping that goes to each one and it fills up so the roots get what they need. I had to figure out how to get about 500 meters squared of these crops into the smallest area possible. I tried many different growing spaces and eventually wound up with a rectangle and rolled it up to what is basically a spiral that's vertical. It's a lot more efficient. I had to research biology to understand the plant growth structure. I had to research, engineering and how these things hook up together and the life support systems and the gases that are needed for breathing, and it's definitely a challenge. There's a lot you have to know. A lot of fields that all integrate with each other. Here at the university, we all get together, we discuss our ideas, and we go over, what each person's project is and how it integrates with the rest. While we all do our individual work, we talk amongst ourselves and we discuss our ideas so that it all integrates into one giant project.
We design, we test, we build, evaluate, and we learn from that. A lot of times what we do is we take different design concepts and we make them out of very low-tech materials like foam core, and we build them quickly and inexpensively so that we can try the concepts out. We're a very dedicated group of people that want to ensure the safety of the crew members, but also to explore and provide the concepts and designs to help them explore.
The most fun about what I do is most definitely the fact that it's brand new territory, that there isn't a Martian greenhouse that's up and running yet. The field is not flooded with information. I've got the potential to really add to it or to really start something new. It's really exciting.